Hey guys, welcome back to my channel, the Tech Coders, and today we are going to solve problem number 1872D of Codeforces, that is plus minus permutations, and this was the part of Codeforces around 895 division 3. Okay, so with the help of this example, that is for n is equals to 7, x is equals to 3 and y is equals to 3, let's try to understand what exactly question is saying to us. So yeah, I can see that over here I'm having that example. So n means that is the number of elements I'll be having with me, that is from n up to n. Okay, like 1 2 3 4 up to n. Okay, what is x? So over here x is equals to 2. So what I'm going to do, I'm going to take the sum of all the elements whose indexes is divisible by 2. So let's first do indexing, that is 1 2 3 4 5 6 and 7. Okay, so for x is equals to 2, I can say that I'm going to take this, I'm going to take this, and I'm going to take this. Okay, and what is y? Y is also exactly the same, that is I'm going to take the sum of the elements whose indexes are divisible by y, and over here y is 3, so index is divisible by 3, so this will be my y. Okay, this will be my y. Now let's take out their sum. Their sum will be like this: 6 plus 7 plus 4 minus 1 plus 4, 1 plus 4. So according to traditional mathematics, this 4 and this 4 are going to get cancelled and my sum is equals to 2. Okay, we have to perform these operations in such a way that this difference should be maximum. Okay, as I can see that for this case and for this arrangement, initially my arrangement would be like this. Yeah, initially this was my combination, so after performing the permutation means the possible arrangements. So for this arrangement I can see that I'm getting the maximum answer. Okay, so now let's try to get my point that let us suppose that if I'm subtracting a and b and I want their difference to be maximum, so I know that this should be maximum and this should be minimum. Okay, this should be maximum, this should be minimum. Let us suppose that if I want to subtract two elements from this given sequence and the difference should be maximum, so it is obvious that I'm going to take 7 and 1, then only my difference will be maximum, that is 6. If I'll take 6 or 5 or 3 or 2, let us suppose that if I'm taking 6 and 2, so I can see that my sum is not my difference is not maximum over here. Okay, so that's why I'm saying that a should be maximum, b should be minimum. So now after getting this concept of maximum minimum, you may be having one thing in your mind that I'll place all the maximum elements in the indexes that is divisible by 2 and all the minimum elements that are divisible by 3, and after that I'm going to do the subtraction part. Okay, so let's do that. So now see, for n is equals to 7, how many indexes I can have which may be divisible by 2? It's obviously that is 7 by 2 is gonna be 3, and for y it is gonna be 7 by 3 is equals to 2. Okay, so now I can say that I'm going to take 3 maximum values and 2 minimum values, and after that we are supposed to perform the operation. Okay, let's do that. 7 plus 6 plus 5 minus 1 plus 2. Okay, so what will be my answer? That is 7 plus 6 is 13 plus 5 is 18 minus 3 is 15. Okay, so yeah, I can see that I'm getting the greater difference over here, but yeah, this is not the maximum, this is not the correct answer over here. Why? Let's try to get my point. Okay, what was my combination? It was 1. This was my indexing 1 2 3. What I said that I'll place maximum elements for indexes divisible by 7, so I'll put 7 6 and 5. Okay, and I'll put minimum elements for the indexes that are divisible by 3, so I will put 1 over here, and now try to get my point that according to this I should be putting 2 over here. Okay, I should be putting 2 over here, but I can see that as already 5 is there, so I can't put 2 again. Okay, as already 5 is over there, so I can't put 2 over here again. Okay, so that's why I'm getting my answer as wrong. Okay, so now what to do? I know that this should be my maximum value. Okay, so I'm saying that I'm not going to change the place of this 7 6 and 5. What I'll do, I'll keep on placing minimum elements in the indexes that are divisible by y, and if I'm having some values over there, then I'm not going to do, I'll simply move on further. Okay, I'll simply move further. So let's try to get what I'm saying that. Okay, what will be some of this maximum element? It is gonna be like this: 5 plus 6 plus 5. Okay, minus, I'm having 1 over here, so 1 plus, now see, as I'm having 5, so rather than putting any other number, I'm just going to take 5. Okay, again this 5 and this 5 is gonna get cancelled and my answer will be 12 over here. Okay, and my answer will be 12 over here. So now see, I can see that I'm getting 12 and I'm getting 12 over here. So what I have to do, I have to place all the maximum elements in the indexes that are divisible by x, and minimum elements in the indexes that are divisible by y. And if at any particular indexes I'm already having my value, that is the maximum value, at that time I'll simply move on further without doing anything. I can see that over here, after cancelling this element and this element, I'm just adding this two and this one element. Okay, that is this two and this one element. Now what element should be get cancelled over here? What element should be get cancelled over here? So let's try to get that. Okay, so now see what we are doing, we were placing the maximum elements in my index that is divisible by x. Okay, so I'll do first that. Right. Now indexes that are divisible by y, I'll be putting minimum 1 and 2. I'm not going to put this 2 over here, but see what I'm saying. I can see that the indexes which are divisible by both x and y, that is both 3 and 2, are going to have the same values. So can I say that I will find the number of indexes which are divisible by both x and y, and I'm not going to consider those indexes, So now let's try to get my point what I'm saying. That is, see, this is divisible by x, that is 7 plus 6, minus this is divisible by y, minus 1, and I can see that over here as I was so over here I can see as this indexes were divisible by both of these indexes, so even if I'm going to add and subtract them, they are going to get cancelled, so it's of no use. So what will be my answer? My answer is 12. Okay, my answer is 12. So now the question arises, how many such indexes are going to be there? So see, there are two ways to get that value. That is, you keep on iterating from I is equals to 1 to I is equals to n and check if I is divisible by x and y or not. If it is divisible, then you can increment or count, and ultimately you will be having the indexes which are divisible by both. Okay, so now let's try to get the second way. That is, I'm saying that find the first index that are divisible by both of these x and y, and after that divide that index by n. Okay, divide that index by n. Like as I can see that as the first index was 6, so 7 by 6. As it was 1, so yeah, we were not taking this index value, that is the count of such indexes is 1 over here. Okay, so now how I can get this 6? Simply what I'll do, I'll find the LCM of this x and y, that is 2 and 3, and it is gonna be 6. Okay, it is gonna be 6, and what I said, the count of such indexes will be n divided by 6. Okay, n divided by 6, that is the LCM. So now the question is, how can we find the LCM? You may be aware with this formula, that is a into b is equals to LCM of AB into HCF or GCD of AB. Okay, so we are having the value of a and b and a function which can find GCD. Okay, so what will be my LCM value? My LCM is gonna be a into b divided by GCD. So now see, I'm having my LCM as 6 with me. Okay, so what I did over here, I just excluded the indexes which are divisible by both of them. So how I was calculating the number of those indexes? That is n by 6. Now we are going to do very simple thing. That is, how many indexes for x were there? That is 3. How many indexes for y were there? That is 2. Okay, now just subtract the common index which are possible in both of these combinations. That is n minus 6 over is 1, 3 minus 1 minus 2 minus 1. That is, I'll be having 2 values for x and I'll be having 1 values for y. Simple. Now as I have to take 2 maximum values and 1 minimum values, what I'll do, I'll take out this sum, and I'll just subtract them. Okay, now how to get this sum? Okay, it is also very simple. We have discussed it earlier in some questions. Okay, as I have to find the sum of this 2, so can I say that at first I'll find the sum of all the elements, that is from 1 to 7, and I'll subtract as that is 1 to 5. Okay, then I'll be having the sum of 6 and 7. Simple. Now the question arises how to find this sum. Rather than going one by one, I'm having one formula, that is the sum of n natural number is n into n plus 1 by 2. So what the n over here? That is 7 into 7 plus 1 by 2 minus, that is 1 to 5. Okay, so what is this value? That is the number of indexes which are divisible by x minus the common indexes. So let us suppose that value is a1 over here, and that is 2. So what I'll do one thing, that is 7 minus 2 into 7 minus 2 plus 1 by 2. Okay, I'll be having my value, that is 13 over here. Simple. And what I have to subtract? I have to subtract this 1. And what is this one? That is the number of indexes divisible by y minus the count of common indexes. Okay, let us suppose that it is a2, and its value is 1. So what will be this? Its sum, that is 1 into 1 plus 1 divided by 2. So this will get cancelled and I'll get my sum as 1. Okay, so what's next? I will simply subtract that 13 minus 1 is equals to 12 and I'm getting the maximum answer. Okay, now let's move to the coding part. As given in the question that there are 3 variables, so yeah, they are n, x and y. I am taking their input. So now see, the count of indexes that are divisible by x is gonna be a, the count of indexes that are divisible by y is gonna be b. Okay, now I'm taking out their sum, x into y divided by cd of xy. Okay, that's it. Now I'm with my sum. So after that we are counting the number of common indexes. Okay, so these are this, that is n by LCM. That's it. After that we are subtracting this common indexes from the count of our actual indexes. This is what we are doing over here, that is a1 and a2. And after that we are finding the sum of a1 elements, that is maximum a1 elements, and after that we are finding the sum of minimum b1 elements, and this is what we are doing over here, that is sum of n elements minus sum of n minus a1 elements minus the sum of b1 elements. So yeah, now we are done with the logic part and the concepts and all. Okay, I hope you understood all these concepts and all, and if you are having any query or doubt in any particular part in this question, then just feel free to comment over there. We'll definitely help you to come out of it. Okay, so thanks for watching and have a good day, guys.